Hey, math friends. So our learning target today is I can interpret circle graphs. So we talk about circle graphs. We are kind of looking at a couple different things. We're talking about the category of degrees, because we know that we have 360 degrees in a circle. And then we can also be thinking about kind of what percentage of the circle is covered in each sector. So just a little overview of how circle graphs work. So we know that the red section, we can say that the red section, I think I'm actually going to undo that, but we can say that the red section is 180 degrees. So that's one way to look at it. It's 180 degrees out of 360 degrees, which is 50% of the circle. So if we're talking about what's the percent chance that you get red, you would say 50% chance that you land on red. Likewise, blue would be 90 degrees of the circle, because we know that that's a right angle. We see that right angle symbol. We know that this is 90 degrees out of 360 degrees. And we know that that equals 25% of the circle, or 1/4 of the circle. 1/4 and 25% are the same thing. This is just an overview, so you don't really have anything specifically that you're doing in your note taking. And the green section is a right angle here. And we know that that's 90 degrees out of a full circle, which is 360. And as I just stated, that's 1/4 of the circle, which equates to 25% of the circle. Of course, we want all of the percentages to add to 100. And we want all of the degrees to add to 360 to complete one full rotation of a circle. So just things to be thinking about as we go. So we're talking about two different categories: degrees or angles, which should be 360 for one complete rotation of a circle, and then percentage. So two different categories. We've dealt with percents this year, and degrees you've dealt with in elementary school. So you've covered both of those categories pretty frequently over the course of your career. So let's talk about this first example of what is a circle graph. So a circle graph displays data as sections of a circle. So we have different sections or sectors of the circle. When you add those sections up, the sum of the angle measures is 360, as I just stated. 360 degrees, which is the same as 100% of the data. So it's saying in the language here, so this is all just definition stuff, that the percents total 100%. Each section represents part of the data. So we have apples, bananas, and we'll say oranges. And then the circle has to be 360 degrees. Again, just notes happening here. Just notes of the circle. So if I were to say, what is the probability that I land on an apple? Well, we would say, well, that's 40 out of 100% of the circle, right? Now, that doesn't say how many degrees. It's not 40 degrees. In fact, it's an obtuse angle. If we really look carefully here, we have an obtuse angle. And from back in elementary school, you know that that for sure is greater than 40 degrees. It's greater than 90 degrees. So then we could use cross products to figure out how many of the degrees represent apples. So that's the overview of what we're going to do today. All right, so we're going to just take one section here because otherwise it would be too many sections. But the way that we would construct a circle graph essentially is that we would find the total number, we would find the angle measure, we would take cross products, and we would sketch the graph. So we would take the data and basically convert it into degrees. So if we took a look over here, how many total people were surveyed about their favorite amusement park? The choices were Disney World, Busch Gardens, Universal Studios, or Marineland. So if we were to add those up, we get what? 40, 50, 60 total amusement parks. So that's step one, get the total. Next step is to find the angle measure through cross products. So let's just pick one of the categories. Let's say Disney World. So what's the probability that they chose Disney World? Well, Disney World we had 25 of 60 chose Disney World. So how many degrees is that? Not 25 degrees. How many degrees? Well, degrees are measured by 360. So the question is, how many degrees on a circle graph would represent Disney World? So we would take cross products and solve. Because of space, I'm not going to show my work on that, but you can go ahead and do that for sure. Looking at how many degrees for Disney World. So we would come up with that it would be approximately 150 degrees for Disney World. So if we were to sketch the graph then, if we know that this is 180 degrees, and we're looking for how to represent Disney World, we would say, well, Disney World then would represent maybe about this obtuse angle, approximately 150 degrees. So I'm going to erase this little section here. So approximately, this is the representation of the people that chose Disney World as their favorite amusement park. It comes in two categories. It comes in the category of the percent of people that chose that, perhaps, or the number of degrees. In this case, we're choosing degrees. This number of degrees represents Disney World. All right, let's take a look at another example. I only used one category in that. We could have done that for all the other ones, but the video would get super long if we did that. So this table shows the dog and cat ownership among the teachers in our school. Display the data in a circle graph. Again, we're only going to choose one category, but if we talk about the percent of people or the probability of people that chose dogs only, people that only have dogs, we see that 30% of our staff only has dogs. That's 30 out of every 100 people. But we're not talking degrees here. We're talking people or percentage. So how do we get from the percentage to figure out degrees? How many degrees is that then? Is the real question. Out of 360. So to do that then, we would take cross products to solve. And we would end up getting 100x equals the quantity of 30 times 360. So we're going to divide both sides by 100. And we find out that the number of degrees for each of those categories is 108 degrees for the people that have only dogs. It looks like cats is the same. So we would represent that. If we know that this is 90 degrees, right? Then that would have to be slightly bigger. It's on an obtuse angle that's slightly bigger than 90 degrees. So this would be something like we would represent here of this is the category of the people that only have dogs, approximated on my graph representing 108 degrees. Now, again, if we were in class, we would do that for cats and both and neither, and we should create the entire circle graph. But the reality is at this day and age, you would do that in a computer program. But I want you to understand the why. Why is that happening? So let's take a look at the next category. All right. So again, we're not going to do all of these, but we will do some. A department store has $7,200 in sales. Whoa, messed that up. What is the amount for each category? And again, because of time, we're not going to do all the categories, but let's start with shirts. All right. So shirts represent 140 degrees. Cool. Out of what? Out of 360, out of the whole circle. So we want to know how many dollars does shirts represent out of 7,200. So when the department store had sales in shirts, how many dollars out of, there's our out of the 7,200 did they sell? So I'm simply going to just take cross products there. Not enough room to write, so I'm not going to solve that out. So when we take cross products here, we find out how many dollars represents this category here of shirts. How many dollars does that represent? And I'm coming up with $2,800 for the shirt category. So we would do the same thing for the other categories. Again, but we're at 10 minutes already, so I'm going to skip the rest of those categories. but hopefully that gives you the general idea of how we would take the number of degrees and convert it to like money or percent or something like that. And then also the flip of that. How would you take percents and convert it to degrees? So we've seen both angles of that. All right, we're going to try this one. The circle graph shows the results of a survey of 80 students on their favorite fruit. Which fruit is the most popular? So this is the first question. You can see that we'll call it orange. Maybe it doesn't look like an orange to you, but that's what I'm going to call it, an orange. You could argue it's a peach, but down here it says orange as well. So we're going to say orange is the most popular. It represents, as you can see, 50% of the circle, which is also 180 degrees because 1/2 of the circle, right? So now, compare the number of students who chose oranges versus those that chose apples. So let's take a look at how many chose apples. Oh, that's all connected as one. All right. So apples, how many chose apples? Well, let's see. Apples represents 45 degrees, 45 degrees of the circle. Not 45 people, 45 degrees out of 360 degrees. And we want to know how many students chose apples. So how many students out of 80 chose apples? We take cross products to solve. How many students chose apples? You should pause the video at any time when you're trying to solve. This is your journey, your work. You should be doing that. And you should be coming up with that we found out that 10 students out of 80 chose apples. Now, a very simple, easy question here is about oranges. They're asking how many students chose oranges. Well, if we take a look at the graph here, we can see that 1/2 of the circle is oranges. And if we surveyed 80 students, 40 kids chose oranges. So that should be a pretty easy thing to break down there. All right, let's go to some other examples. I skipped that last question on bananas again because I don't want the video to be super long. But what is the central angle of the sector that shows the percent of bread baked? Okay, so we have a situation here where we're talking about this category of bread, which represents 35% of the circle. Not 35 degrees, 35%. So that's why we keep jumping back and forth from percent, 100, degrees, 360. So 35% is 35 hundredths. And our job is to figure out how many degrees is that. So you can see here that it's definitely an obtuse angle. And all of our answer choices are obtuse angles. So that doesn't really get us any further ahead. But if I take cross products on that, what do I get? So pause the video, try it out. So 35%, how much out of 360? Oops, I'm just realizing that I have a mistake here. I took the wrong category. Couldn't figure out what was going on. That's why I paused the video. But when we really look at this, we're talking about the bread category. Maybe because I love cake so much, but I took the wrong category. So hopefully you're like, wait a minute, what is she doing? The bread category is the category I should have been talking about. So this category here. So I had a big boo-boo there. So I'm going to backtrack this. I can't rewind the video or I would have fixed it. I don't know how to rewind the video. So 40% is 40 out of 100. So there is definitely an error that was made there. So I'm trying to fix that now. You should be coming up with 144 degrees is the section of that bread section. So I apologize for that error. I was doing cakes instead of bread. My eyes are getting bad. I couldn't really see the screen too well. So hopefully you caught up on that. So that is the category for bread, which also represents 40% of the circle. All right, my fault. Sorry about that. All right. Next question. Mr. Feldman spends $2,000 per month to rent his workspace. He spends $8,000 in all per month to operate his business. In a circle graph of his business expenses, what is the angle measure that represents rent? So what he's saying is this, that he spends $2,000 out of $8,000. How many degrees would that be on a circle graph? If he spends $8,000 and $2,000 is just to rent the office, it doesn't include electricity and water and all those bills that come with it, just for the rental of the space, just like your mortgage kind of situation. So we're going to take cross products and solve. I'm going to have you pause the video. Hopefully I didn't make a mistake this time. I apologize for that. And you should come up with that it is 1/4 of the circle, or 90 degrees, on the expense of just the rental of the space. Okay, and let's see. Find the angle measure that corresponds to each percent of the circle. So we're only going to do one. We're going to do this one. So if you have 70% of the circle, we're asking how many degrees is that? So simply take the cross products, pause that video, give it a shot. And you end up finding out that it's 252 degrees for 70% of the circle. All right, guys, so our learning target today is to interpret circle graphs. So the things that we talked about is that at the very beginning, we talked about how things can be broken down into different pieces. This looks a little different at the beginning, but this is 1/2 of the circle, right? Which represents 50% of the data and also 180 degrees. This represents 1/4 of the circle. 1/4 of the circle, which represents 25% of the data, and 1/4 of 360, of course, would be 90 degrees. This represents 1/8 of the circle, which is 12.5% of the circle, which is 45 degrees. So there's just different ways of looking at different scenarios. Are we looking for percent? Are we looking for degrees? What are we trying to do with the circle graphs? So that's the summary of our lesson today. I can interpret circle graphs. I apologize for my mistake on the bread. I read the wrong category. Have a glorious night. Woo!